Hello everyone, this is Nilson Lima and welcome to the presentation of Cloudscape Seasons, and this is a small tutorial showing how to use the assets. And just make sure that you download the config folder here at the store page since you want to run the demo maps. This is the best configuration, and you overwrite a project you just made to include the asset. But if you are using your own project, it's recommended that you don't overwrite this. Okay, this is just for running the demo maps and nothing else. Okay. Now getting back to when you download it and you open the project for the first time, there will be a lot of shaders compiling. You have to wait all of them to finish. Okay, that will be like 10 shaders that will take a little bit more time to compile, so you have to wait for those. And once you are here, if you want to see the clouds right out of the box while you're doing here in the editor, you need to click on BP Cloudscape Seasons and check the development mode. Okay, then your clouds will show up. Okay, basically when you run the demo, you have brought a menu. In this menu you have 5 maps that you can, with Alt 1 through 5, you can go to each of these maps. You have a watch at the top left corner, and a menu, and you can change the scalability, the number of rays, the texture resolution, if you're in full HG or just HG, if the clouds will cast a shadow into the ground, and if we are turning on or off the jitter. So in the bottom menu, there are the keys that when you use, you'll see those changes. So right now we are using a 2K texture resolution, so if you bring like 0 at your keyboard, you have now 4K textures. Okay, and you can like type 7 to have 256 rays, 8, 9. It seems that not much difference happening, but I will show you guys when you crank this back to what it was. And now I start to use page up or page down to increase the coverage in the sky. I got quite a lot of clouds here, and now I'll change back the texture for 4K, and now start to increase again. 7. Now the maximum rays recommended. Right now we are really taxing at performance because 512 rays is like a lot. We are under a massive shadow here because the sky is completely blocking the sunlight. So if we just page down, you crank up the amount of clouds in the sky again until you start to see some light coming out. Right now I'm out of the cloud shadow. I'm running against it. So there you go. There will be another shadow coming. You guys can see it's just covering us. And inside your content browser you can navigate to a series of folders. One of them you have the maps folder, and you got here each of the maps I have prepared for you to see. Don't need to save. It's the same thing. Click on development mode and you got your clouds. You have a moon. This is about the same. And you can see the sun slowly is moving through the sky. We have prepared the 30 seconds to be equivalent to 1 hour. So if you want to change this, you go to the BP calendar seasons, and at time unit you can change like for 2, so each hour will be 2 seconds. So now you can see the sun is moving faster. It is recommended that you see it is doing it slowly, because you can see more how the sky changes, how the moon rises and the stars take its place in the sky. So basically this is what you get. Now the moon starts to set, for the sun start to rise right there. And so for understanding how the system works, it is important to figure out how to build a level from scratch. So what we're going to do is like shift to this dim a cloudy day. You see the clouds now get dark. You just set development mode again. You have everything set for what it was before. And just for us to do this, what I'm going to do is that I will delete everything here except the landscape. We don't need this and this. That's it. Just for starting, first thing you need to get here is to place in the blueprints folder. The blueprint folder will start to get first of them a BP Cloudscape viewer, Sky Seasons, and for the wind seasons you click on it here in the outliner and press Ctrl W, so you make another 2 copies, rename this one for 1. You need 3 layers of wind, because you can have 3 layers of clouds. And the thing is now, you see that are some of the, like the BP sun and moon and the calendar, we did not push here yet, because I want to show you guys just the basic setup for this. Another thing that you need to bring is in the lights here, you need a skylight. So you see that once I bring the skylight, it just made a capture and like blended with your environment the majority of the colors. It seemed like we have this oranges here, so this capture make it reflects this orange color on your environment. You can set this to movable, so it will be more pronounced now. Another thing that you need is 2 directional lights. So we bring these 2, and one of them, let's make them movable as well. One of them we'll call sunlight. And another one we'll call it moonlight. Okay, and let's set up on the sunlight pi, and for moonlight something very low. And now you see that it's something going on here. It's not precise yet, and explaining here, BP Cloudscape Seasons holds all the settings to make the clouds. Cloudscape Viewer is the responsible to bring the clouds drawn into our sky, and BP Sky Seasons is responsible for the stars, the sun and the moon drawing, and the moon phases transitions, and the colors you can see in the horizon and the zenith. Those are responsible for Sky Seasons. So let's start to check Sky Seasons and see each other parameters it needs to make this sky correct for us. First thing here is asking for the skylight, so we just click here and select one. It asks for a volumetric fog. We don't have to, so you'll leave this right now. It's asking for a sunlight actor, and you see that once I have picked the sunlight, the sky already changed, and we can see now our sun drawn into the sky. He asks for the Cloudscape component, so you give it to him. Asks for the, if you want to enable moon and a moon, let's enable the moon and let's get the moonlight. This is the BP, the moon. We don't have it, so you leave this right now. We don't need it for what I have to show. You don't need it to change this as well for now. We're just making a scene without many things. Once we have set the Sky Seasons, now we're going to Cloudscape Viewer, because there are a few things you have to do. Cloudscape Builder component is the Cloudscape Seasons, and Landscape is your landscape. If you are using an actor like a mesh, you can change the type here. I will make sure that in the next version I will change the type so we can have actors or landscapes being selected here. Okay, once you have selected both, we have to look at here later, but I right now place here minus 40,000 because I know this is work. And we'll play Cloudscape Seasons now. We can start looking for any field asking for an asset and is written as none. So Cloudscape Viewer component, layer 1 for wind. Let's select our first, second, and third. Keep moving. Ignore every field unless you see something written with none. I'll explain the other ones later. Asking here for the sunlight. Asking here for the moonlight. And that's it. We have settings here as well, but we are not dealing with them. Once you have done this, and still with BP Cloudscape Season selected, you will click in development mode, and this shall bring you your clouds. Okay, we are with different cloud visual. If I press here, so we are back here. I have deleted all the items here in my level blueprint, so we can get back here. leave this checked. So we are talking about that our cloud here is just different from what we have before, because there are some parameters here that were tweaked. These parameters, I've explained them here in detail by the purpose. And like jitter, if you look at the edges for these clouds here, they get like a little sharp corners sometimes. It's not smooth out, and as you can see here, when I look to above, you can feel that it's not that smoothed. So if you have here and play with jitter like 1, it's smoothed quite a lot. This is also important if you are going to navigate through the clouds. So let me bring this here faster. If you see close to the clouds and I place back the value to 0, you start to see a lot of these artifacts. And these artifacts, there are 2 options to get rid of them. One is playing with jitter, so then reduce them a lot. And another thing that you need is the ray-marsh steps. Ray-marsh steps, if you are not familiar with, is the amount of rays that are cast to the textures, so you can have more accuracy representing your clouds. And if we just I know already the value 320 is a value that now you see no artifacts while we are moving. I'm now moving and you see that is hardly you get your artifacts. So the experience on traveling through the clouds is better when you raise up the ray-marsh steps. You can do this with your blueprints if you have like an aircraft that needs to be traveling through the clouds. So this is quite what you would expect on doing in this case. There are some parameters that they are meant for performance and you don't have to mess with them. One of them is sample cutoff. You have to leave this in this value. Cloud movement update. When you're playing, we just don't have a start player here. Let's place our player start here. If you guys notice, the clouds are now moving to forward and to the left, and that cloud update time here is this. So it is 0.15 seconds or 150 milliseconds. These 2 values here, you have to feed them like they were vectors. We are just carrying for the X and Y, so you can like move the Cloudscape viewer. If I just press F, you see that is this big cube where the clouds are drawn. It's really huge. Okay, and so filling those values like with our aircraft while it is moving through the X and Y axis. So based on your starting point and your current position, you subtract them and you feed here these values for the x and y separately, and you will move the cube along with you, so you'll not reach the limit of the cube, because beyond the limit there will be no clouds. We are having a future version that this movement will be completely done for you automatically, so you don't have to code it yourself. You just have to select it here and choose which is the actor that needs to be monitored for its position, so the displacement value will be added here automatically for you. These values here, you don't mess with them. Skin percentage in separate translucent skin percentage are the same values that you'll find in your post process or in your CVARs, and they're meant to reduce the number of pixels you are using to draw your scene, so you can have a little bit more performance. This is good because when you raise these Raymarsh steps to a large number, using less skew percentage or translucent screen percentage, you have more performance. Cloud density is better said than done. You just make attenuation on the value weight for each pixel, use it for composing the clouds. So a value near 0 is not allowed, so you can have like very dim clouds, almost nothing, to something. Again, you can control this in several ways. The tails balance, you see that some rounding or small details are added once you get for each side of the value. Leaving it at 0.5, you have this wind turbulence influence is how much the wind will make your edges move. Regardless the speed the clouds take to run. So the clouds is still moving approximately at the same speed, but that turbulence is like higher. It can be used for some sort of effects if you need to. 0.5 is a good balance. Turbulence amount is how much you are adding noise to the edges. Extreme values you make extreme clouds. So 0.2 is enough, but later you see that when composing your clouds, you can change these values depending on what you are doing with your materials. And the minimum density, it means how much into the cloud, starting from the edges, that you see this turbulence affecting more. So like 0.3 is a nice value. You make it a little bit more crispier your clouds. You can again control here. This one is going to left the project in the future version, so don't care about this one. And now we are starting to see animation about curves. Curves, if you are not familiar, curves is a way for, instead of having a single value like this cloud overall color, if I click here, I can change this parameter. It will change the overall cloud color, so we can give it any kind of color we want. Okay, but once you leave it here, from morning to the end of the day, your clouds will still remain with the same color. It is the one you have set here. We have into the system a way based on the sun position to make a lookup on a table, and this table is the curve asset. And for each sun position, you have a different value for overall color. So once you enable it here, the BP Cloudscape Seasons will use this asset here. More documentations about this you'll find in the Unreal documentation space on how the curves works. But basically, if I click here in the magnifying glass, it will show me all the curves being used. You see that for zenith, horizon, we already have some mappings telling how the colors will behave depending on the sun position. During the day, you see a more bluish color, and afternoon or morning, a reddish color or orange color. Okay, basically this is how in all we drive the location inside this curve is based on the sun position. So if I open one of these, it is colored, it will start that you see some little diamonds. These diamonds here, they are called keys, and if I set here, it says to me that this one, it is the alpha, have a value of 0.6 when the time is -1. This time here you read then as the sun position when it is closest to the dawn. Okay, when it is morning or when it is end of the day, afternoon. And here we have our red channel. Here the time is -0.39. Here the times are 0, and they are assuming another values until the last value becomes a constant. So anything for this color here bigger than time 0.47 will be constant blue, 0.19, and for the green 0.08. Okay, this is how the curves works. If you see here, this until here you have completely black because we are night time at this portion. From here, almost night, the sun setting position, it are the same for the morning, and here when are still the dawn is still coming, and here is during the day, and you have the fixed blue and green and red representing this bluish color down here. So basically this is the explanation I can give. If you are not familiar with, you have again to look at the Unreal Engine documentation. For there are these are called color curves, you also have float curves. Here, as I have a color, there are some other places that I'll need just a float. But the principle is the same. It's the sand that will drive that value, even being just a float. This is our viewer, our wind layers. Don't change these values. They are here like an adjustment. So it's tweaked for this to work. You can later, when you have a better understanding of the system, you can maybe start messing with this, but we are changing the wind components in the next release to have more features. So maybe we'll get rid for this value here. Coverage resolution is meant for how much, how large is the texture we are using to represent the clouds in the sky. And here is the size of the clouds that gives us the noise to make the shapes for the clouds. We have one if it is a base and more detailed one. And this one represents the turbulence we see at the edges. This is a very specific kind of material. This is a curly noise used here. These are light functions to make the cloud shadows, and this is the size of the texture being used. You see that we are using whenever we want more performance, small sizes, and when you want more details, bigger sizes. So every time you say a bigger texture, it means more performance is being drawn from your system. This section below, you have just shadows. So shadows, you have the same concept here, are the steps. We can look at against the, we can use this portion of the clouds that are against the sun, so I can explain how the shadow steps works. Like if I have just one step, it means almost no shadow. Maybe in a stylized game this would be any useful, but as soon as I start to place some more shadows, some more steps, we start to have some shadows being drawn in your system. So 6 is the minimum when you still have a nice performance, and you see that there is a limit, like 12 you get better, but if you change this like for 20, basically there is not much difference. Okay, so 6 is a good measure, and all depends on colors and all other aspects you are choosing for your clouds. And shadow density, it's how darker will be the shadow drawn here. So this is a good value, but even if you get it a little bit more, so how dense it can become until it swallows our cloud. Okay. Shadow distance, it means how far from the edges the shadow will start. So if you give this even smaller value, we have now a real tiny amount of space here. Light shift, it's a second adjustment saying it is the angle the light will be adjusted here to give you a more pronounced effect. So 1 minus 1 and so we are now even closer to what we were seeing before. Distinction color, you got the same thing. You got curves to drive the values, or in this case, distinction works on the exactly in the transition from the shadow to the illuminated area by the sun. So you can give like a reddish or pinkish color. It only affects the transition. Something may bleed, so you have to use carefully these values, but the goal is this. These are tweaked values for the ground cloud shadow. So the shadows you see here, they are tweaked by these values here. So it is good to you to use the default ones. You can make the shadow a little bit blurred, increase the blur radius, give you a sharper look if you wish. This place here and below, we are dealing with the sun and moon and sky attributes. And again, you have a curve, or you can tweak the value. For those not familiar with anisotropy, anisotropy is the effect that you can see when you have this green light effect in the clouds. Higher anisotropy value means that all the clouds in the neighborhood will be equally enlightened in this place. The lowest the value, you can use even negative values, will produce, like I'm showing, a radius around the sun where the clouds are more affected, while far away they are not that affected. You see the difference? This is not usual for sun, but it's great for the moon. Sun color, you can also drive the sun color during the position it has in the sky. And here for the alpha, you can increase the lighting contribution here. So if I place here 50, you have more light. Okay, it still looks for the anisotropy values. Okay, and the RGB will just give the colors. So this basically affects every place in the cloud where the light touches, the light from the sun. Or during the night, the light of the moon, and you have the appropriate color picker for that. These values means it is the minimum amount of light, because when you are like the sun is like setting, maybe you wish that even when it is already below the horizon, we still have some lighting on the clouds. So the mean value, it means it is the minimum amount. Again, this from 0 to 1. The max sunlight, it's even with the sun at its peak, we can darken these maximum lights. Okay, even you can go beyond 1, it's not recommended. I think, yeah, These angle corrections are values that helps to tell exactly which is the lowest angle you want to see this value starting to affect, and the max angle the same here. So these two are related to these two. You have here the sunlight actor, how many times it will take for you to update the sunlight angle shining on the clouds. So 200 milliseconds is like what you need. So the same anisotropy for the moon. So at night you can have a halo around the moon. It is quite nice. The same thing for the color. So the moonlight, in alpha you drive the amount of rimming light you have on the clouds. This is the same explanation as for the sun, the minimum and maximum light and the angles, the updating interval, ambient lighting. It's better if I turn off so you guys can see. It is meaning the bottom of the clouds are not receiving any light from the ground. Not that is really the light of the ground. You can tell it is the light. In this case we are using something like bluish. It is this color here. You also have a curve, but you can say, because you have all this green, that you have something more greenish, or you can stay at white, and you can give some gray. And in this case we needed to fix the extinction color here, so you have a pure gray down here. This controls the coverage and sharpness and density levels for all the clouds based on the values you have here. When I say all the clouds, I mean the cloud layers. You can have 3 layers. It means 3 distinct layers of clouds. So you can have including different types of clouds if you have modeled them in materials, or have the same with different attributes, and you can combine with the wind direction and have like each layer with a different direction. So for you to see, we have here the layer 1 enabled. So this is like you can play a little bit with the altitude for this specific layer. This value here in Cloudscape Viewer, it looks like it does the same. It looks like it does the same. I have to place it here. See? It looks like it does the same, but it takes this much because all the transitions I'm choosing here are being sent to the material. So besides this taking a while to happen, depending on your system and your speed, and you can run out of video card memory. So you have to take care when using these sliders. It is better if you type the values here. So back to our layer 1. This is what this effect is. Upper cutoff and lower cutoff, it helps with, I'm sorry for that, helps with performance. So if you know that your clouds are not getting below a certain level, like 0.5, the rays we cast, you like reach to 0.5 and you not consider, and just starting from 0.5 and up. And if you know that your clouds are not going below, is not reaching 1.0, you can like the clouds will be evaluated up to 0.8. So you have a thin margin for the clouds to be evaluated. Like if I place here like 0.7, I start to hit the top of the clouds. So in this case, I ate too much. This will help improve, because it just between these two values it will be evaluated your clouds. So it's a way to gain more performance. Cloud coverage is exactly as I said. More coverage, more your sky is filled with clouds. It might happen that you have some holes on it, and I'll tell you later how to get rid of the rolls if you want to. There is this coverage scale, is about the scale of the noise used. So you can have a bigger noise or a smaller noise. So now your clouds are composed of very tiny small clouds. But as you can see, as we have a full coverage, it's hard to see. So you can play with the density levels for this layer until you find a composition that will suit you. So those are ways for you to transform, and also of course you can play with opacity. Opacity sounds like density levels, but opacity performs in a different way as density levels. Density levels, you are doing a multiplication of this value by the dots composing the clouds. Sharpness, you are using this value here as an exponent for the power function. So a bigger one, it's like get rid of the values below 1, but keep the values no matter how much I increase this, if I still have 1 values, they are kept in the sky. So these are ways for you to easily, with the same material, to compose your clouds. Remember when I have placed the coverage here to the maximum and it still got some holes? Well, these are supposed to help you with that. So radius, greater the radius, less holes you have. You can also actuate on the cloud height, so it make it even more covered. Let's back this. So if I hate the radius, that is some value that you can't increase anymore. See that I'm here at 0.5, and for the height I increase the height of those clouds. So I can have very dim tiny clouds in height. Play with the radius. Different ways to achieve sometimes the same aspect. And the interspacing, we play just with the interspacing, not caring about the radius and the height for the clouds. So interspacing, it is like trying to approach. Sometimes there is no way you change the size, but the idea is to reduce the space. So if I there like at 1, if I play with this as much, I basically can cover the entire sky at its own. You can play with the levels, sharpness, so you can have these sparse clouds, because you have make the interspace so small, and when you play with these values, it means that you have a higher density at the center, but at the edges you lose. See that again, that is just a few turbulence seam, so you might want to increase your turbulence on the top here, like and 0.4, so you have a completely different effect depending on how you do it. That's okay. We are being here placing some values, and right now we have a static sky basically. So this is just a snapshot of a sky given the sun at this position. Okay, there is a moon that you don't know where it is. I need to reduce this speed, or you're every time I'm typing F, for those that doesn't know, type F equals to focus. So we might right now try to explain how the things happens regarding the sun and automating the day and night system. The sun that you can see here is just a translucent material making the sun. It is controlled by BP Sky Seasons, and it draws your sun at the place where your sunlight is. Okay, the more intense you make it here at the Sky Seasons, more bloom you get from this shape here. The same is for the moon. So in theory, you can select your sun, and like here we have its gizmo. Let me place a sphere here, so you can see the arrow here and how the sun is reaching this surface. So I rotated the sun, but now the sun is hitting this part of the sphere, but your clouds and your sky is not updated. If I hit play, they will be updated. But if you want to see how it looks like before hitting play, all you need to do is first hit on Sky Seasons for it to update. So refresh here, it will update your sky. So this is the correct placement for the sun. You can like bring it just a little bit higher. You can refresh again. So that is okay. We still don't have the clouds correctly illuminated because the clouds is Cloudscape Seasons. So now the lights are hitting the clouds in the correct way. It will be the same if I didn't let's just get back to our previous position, like so. Now our sun is there, but if I hit play, our sun is there. See the mountain? The mountain is our reference. Okay. So otherwise I'm placing it just behind that crushed hill. It is the place I have left without changing. See, I have stopped, I have recovered the values at the editor, but if I want those values I have to refresh or update for they to be make permanent. Okay, now you guys understand how those the light for the sun, and it's similar for the moon, happens. Just for the night is controlled by the sun. It means the sun needs to be, like you see here, the sunlight, the arrow is pointing down because it is the direction from the light is coming. So you need to make it the opposite for the system to consider nighttime. So same procedure, you update your Sky Seasons and Cloudscape Seasons. So we got a moon, you got a really bright scene, and this is basically because the moonlight it's too shiny, and the intensity here should be the minimum. Other details like this amount of light in here can be configured in both, like how much the stars are glowing. If you want they not that bright, you can change that as well. But that is a control the Sky Seasons does for us, because when it's nighttime and we have set this, you can say how much the light intensity will be during nighttime and how much time it will take for it to change for us. Localize 30 seconds. So when we hit play, in 30 seconds you see a darker scene. And there is another thing that I didn't mention. It is we didn't set here a post-processing volume. Post-processing volume, you have the exposure, and you might want to control this. Okay. Now still we have just made a static scene for the night. We have other features. It is we have placed didn't place them yet, but we have our calendar. Let's place our calendar and see that the calendar needs the skylight to making the adjustment. You have to enable it to update your skylight for you. You want your calendar and set the day, the month and year, an hour if you want your scene to be. You can have details about your timing settings, like how much hours or time units you can say a day will have. Because if you are on Earth, we know that a day is 24 hours, so 25 time units. But if this scene is like kept in another planet with like a day could be 6 hours. So this is the way you have to change this, and this is the amount of seconds that it takes for 1 hour to pass. So we know that 1 minute has 60 seconds and 1 hour have 60 minutes. So 60 plus multiplied by 60, you have 3,600 seconds. So we have configured here each of these setting here. So if you want to know the amount of seconds your day lasts, this is 2 numbers multiplied. These are the latitude and longitude. You can correctly place your sun and your moon. Daylight savings, if you have this, you can check here. It will consider when positioning the sun and the moon for that specific place in longitude and longitude. And so you can see that we will update each 30 seconds the skylight, and instead here it will be like 20 seconds each hour. So we can like hit play and nothing happens. Why is nothing happening? We didn't check auto advanced time. Still nothing happens. The moon is stopped there at its position. It's because the time is passing, but there is no way for us to change the angle the sun and the moon are unless we put the BP the moon and BP the sun into your level. So for the sun is the same thing. You just choose here, it is your directional light for the sun, your calendar, so we know it is the time, and for the moon the same thing. And now you need to click refresh for each one of them, including Sky Seasons and Cloudscape Seasons. And now let's see where our sun is. Our sun is at that spot, and it is at that spot. Why? Because it is using the October 4th 2017 as a reference, and TNM, this is a 24 hours calendar, and the next release you have a way for you to determine if you want the 24 or the MPM model to set your times. And so if I place this like 6 a.m. and I hit refresh, So our sun is at the east right now. So this place here, and you can see more the horizon is east, and the other one with that hue is west. And this is it. Now we have advanced time setting here, and we have our the moon and the sun. When I hit play, now we can see that our sun is moving. This update is about 0.2 seconds according to the settings in Cloudscape Seasons. So it takes 20 seconds for 1 hour to pass. And so this is how we set up the calendar using the latitude and longitude. You have as well a circular based, meaning that your sun and your moon, you run one after each other in the sky. And certainly this performing a circle, it's not based on latitude and longitude, but it will still use an apparent position based on the hour set. You will not take it day or month or year. We'll still have the time advancing based on the start hour here. And the same way, if I change this, refresh, just in editor, if you can play it right away, it's not a problem. But you see that is already quite different. So our sun is rising at 6. So it's a trajectory quite different from the latitude and longitude ones. And this is mostly how you do go for changing. This is what happens when you don't refresh. If you take your time to refresh, you will see in editor all the things. The next update we have for Cloudscape Seasons is 1.5. This is 1.2. We have several new features that we're going to discuss. I didn't mention this video because there is already videos at YouTube in my channel in a playlist for Cloudscape Seasons. Ways for you to mask your cloud layers. It is this texture here, and it shows how you can make a space where the clouds will not hit, because you can make these clouds go into the ground. If you see the video for the demo, you see that I use the clouds to make a walking fog in the scene. And remember that when you have flying, let's play some more speed here, that you might want a higher Raymore steps. You can also play here some more coverage. So when you are flying, you have much more clouds for you to deal. So you can place and make a beautiful scene from the sky. If you get really close to the clouds, you will see it like it was infinite sky. And one of the features we are introducing in the next update 1.5 is also a way for you for have all the job on saving several sky, sun and cloud states along the entire day. And there are lots of tables where you save those values, and there will be a new blueprint where you can make it play those keyframes. Let's call it keyframes, and it will interpolate by one keyframe for another keyframe, so giving you a different way to build your scene through time. So you can have say how much time from one scene, one keyframe will be interpolated against another one. So you can start a storm this way. You can make the sky clear if just some minutes of playing game, and it looks like the sequencer, but we are not using sequencer. We're doing our own way, because as you guys can see, if you sum up the Cloudscape Seasons and Sky Seasons, you see that we have almost 300 parameters to drive. So we specialize the parameters, so we separate those that affects performance, those that takes care about materials that going to be used, and the ones that only cares about the look, like colors and some other values. So you can save a setup and tell each one of those setups you can combine and build your keyframe. And later on the evolution orchestrator, it is the new asset we're introducing in 1.5, you'll be able to drive those keyframes along a period you define, and all of this keeping performance, so it's good. Another good thing is that passing time, the amount of materials, this is just like less than half the total amount of materials we have now preparing for the next release. So for you to take and not get lost with this much materials, saving them are sets and combining them, it'll be the easiest way for you to make your scene faster, saving data as a knowledge. Like if you tweaking your scene here and you like it, the only way for you to recover this in the future is if you take notes of each parameters you have fed and each values you have fed, and saving them as sets, you'll be able to restore whenever you want those settings. So it's a faster job, and pretty much something that you can do within minutes instead of hours of tweaking. Okay. I hope you guys are enjoying this video. It's a late update, I know, and probably almost not that useful for old owners of this asset, because the new owners are having a lot of trouble following the old videos. So I made this video for the new owners of this asset. They're not keeping up with all the progress we made since 1.5 years ago when we launched this asset. So keep up, guys. Don't forget to rate the asset at the store and subscribe to the YouTube channel to see more videos coming from the new features that will be launched soon. We are having a lot of work. There will be great stuff for you guys to see. Keep up, following us in the Discover server as well. Thank you and bye bye.